So this video is just going to give a few examples of binding energy, okay? So this first question here, all right, the most abundant isotope of helium is helium-4, all right, has that mass. So they asked us to find the mass defect, binding energy, and binding energy per nucleon, okay? The first thing we'll start off with here is that the mass of this helium nucleus, I would prefer to give it in unified atomic mass units. You can absolutely do this conversion. But the mass of the helium nucleus is also just 4.002603 unified atomic mass units. All right? So what we want is the mass defect. So the first thing we're going to do, okay, is find the mass of the nucleons, okay, minus the mass of the helium nucleus. So in this case, there's 2 protons and 2 neutrons. If you look up on the next page, actually, you'll see the mass, the rest mass of a proton and a neutron. I'll be using those. So since there are 2 protons here, I'll use that in unified atomic mass units, and 2 neutrons. All right, and I'm going to subtract the mass of the helium nucleus. Okay. And this is all in unified atomic mass units, and what we end up with here is a mass defect, all right, equal to 0.029279 unified atomic mass units, okay? I'm not worried about electrons here, we're just dealing with the nucleus, all right? So to convert this into the binding energy for the whole nucleus, right, we're going to just do the following. We're going to take the mass, okay, and we're going to convert it into electron volts per c squared. That is going to allow us to directly convert to mega electron volts. Okay, so this mass is now 27.3 mega electron volts per c squared. We're not at an energy unit yet. All right, and the energy itself is just 27.3 mega electron volts. Okay, we plug that into E equals mc squared. So finally, the binding energy per nucleon, if we look at this, all right, per nucleon, which is the atomic number here, excuse me, the A, not atomic number, sorry, we end up with 27.3 mega electron volts divided by 4, and that gives us approximately 6.82 mega electron volts per nucleon. Okay? All right, so that's an example of finding binding energy. All right, and there are a few more examples in the next page. All right, so here it says calculate the total binding energy and binding energy per nucleon and mass defect for oxygen-16, right, whose measured mass is given there. So you're going to do the same thing, okay? Your mass defect, all right, is going to be equal to 8 times the mass of the proton plus 8 times the mass of the neutron minus the mass of the oxygen nucleus. Okay, or you can just write mass of O2, however you want to write that. Okay, and when you do this whole thing, I'm not going to show all the work here. All right, you should end up with this for your mass defect. Okay, when we find the binding energy, follow the same process on the previous page. Okay, but again, actually here, let me show you this really quickly. You want to convert this, okay, as a mass unit, all right? So this is your, your mass here. Your mass conversion factor here. Remember, mega electron volts per c squared. This is an annoying thing, but we have to do it like this, all right? Because we're not dealing with energy quite yet. We want to get to binding energy by using this conversion, which makes life much easier for us. So when we do this, we get this 127.6201, ridiculously long. I know I'm abusing my sig figs here. Okay, you're not finished yet. You haven't found the binding energy. You have to rewrite that the binding energy is this number with a different unit once you plug it into E equals mc squared. Okay. Again, this is the convenience factor of this unit. Okay, being able to convert directly between mass and energy that way. And finally, the binding energy per nucleon is this whole thing divided by 16, okay? So that gives us 7.97626 megaelectronvolts per C squared. Okay? All right, so there are 16 nucleons in there, and that's what you're going to get doing it like that. Final piece here. For number 3, I'll let you guys solve this on your own, okay? But your binding energy per nucleon is going to be 8.56 megaelectronvolts per nucleon. All right? I'm sure you can do this with the information that you have been given. A bit more challenging though, okay, because the units that you've been given are already in MeV per C squared. That's okay though, because you can still do this, and it just takes a little bit of creativity. Just remember that you can either convert this into U and then do it that way, all right, or you can convert the other factors into MeV per C squared. One or the other, but make sure your units are consistent, okay? All right, so that's some good practice right there. You should do that after you finish taking these notes. And also make sure to read about Geiger counters, how they work, okay? And the biological effects of ionizing radiation. We're going to talk about the different types of natural radiation and the alpha decays and whatnot in the next set of videos, okay?